Line voltage refers to the voltage measured between any two live wires in a three-phase system. This definition is accurate. Phase voltage, on the other hand, is the voltage measured between any live wire and the neutral conductor. It is important to note that a neutral conductor does not always exist in all three-phase systems. For example, in a delta-connected system, there is no neutral conductor. In such cases, the phase voltage can be derived by dividing the voltage between any two live wires by the square root of 3, which is approximately 1.732. The term phase should not be used to describe the two live wires in a 240/120 single-phase system. In a single-phase system, there is only one phase. The two live wires are more accurately referred to as hot and neutral. It is crucial to differentiate between single-phase and three-phase systems and to use the correct terminology when discussing them. Here are some additional points to further clarify these concepts. In a typical three-phase system, the line voltages are commonly 208, 240, 480, or 600 volts. The phase voltages in such systems are often 120, 277, or 347 volts, depending on the system configuration and voltage levels. It is important to note that in a single-phase system, the line voltage is equivalent to the phase voltage, as there is only one phase present. In a three-phase system, the neutral conductor is typically grounded, providing a reference point for voltage measurements and ensuring safety. However, there may be instances where the neutral is not grounded. In a single-phase system, the neutral conductor is typically connected to the center tap of the transformer, which helps to create the 120/240 volt split-phase configuration commonly found in residential settings. When working with electrical systems, safety is paramount. Always take necessary precautions, such as wearing appropriate personal protective equipment, using insulated tools, and energizing circuits before performing any work. Understanding the differences between line voltage and phase voltage is crucial for anyone working with electrical systems, as it helps to ensure accurate voltage measurements, proper system design, and safe operation. It is also important to be aware of the different types of three-phase connections, such as Y and delta, as they have different voltage relationships and grounding configurations. In a Y-connected system, the neutral point is connected to ground, and the phase voltage is equal to the line voltage divided by the square root of 3. In a delta-connected system, there is no neutral point, and the phase voltage is equal to the line voltage. To further illustrate the concepts of line and phase voltage, let's consider a specific example. Suppose we have a three-phase 480-volt Y-connected system. In this case, the line voltage would be 480 volts, and the phase voltage would be 480 volts divided by the square root of 3, which is approximately 277 volts. This means that the voltage between any two live wires would be 480 volts, and the voltage between any live wire and the neutral conductor would be 277 volts. In contrast, if we had a three-phase 480-volt delta-connected system, the line voltage would still be 480 volts, but there would be no neutral conductor. In this case, the phase voltage would be equal to the line voltage, which is 480 volts. This means that the voltage between any two live wires would be 480 volts, but there would be no voltage between any live wire and a neutral conductor, as there is no neutral conductor present in the system. It is important to remember that the specific voltage levels and configurations may vary depending on the electrical system being used, so it is always best to consult with qualified professionals and refer to relevant electrical codes and standards. In addition to understanding the voltage relationships in three-phase systems, it is also important to be familiar with the different types of conductors used in electrical wiring. Conductors are typically made of copper or aluminum and are available in various sizes, each with a different current carrying capacity. The size of the conductor required for a particular application depends on the amount of current that it will be carrying, as well as the ambient temperature and other factors. Electrical codes, such as the National Electrical Code or NEC, provide detailed guidelines for determining the appropriate conductor size for various applications. These codes also specify the types of insulation that are required for different types of wiring, as well as the methods for protecting conductors from physical damage. When working with electrical systems, it is essential to follow all applicable electrical codes and standards to ensure safety and prevent electrical hazards. It is also important to use the correct tools and equipment for the job and to take necessary precautions to avoid electrical shock or other injuries. In summary, line voltage refers to the voltage between any two live wires in a three-phase system, while phase voltage refers to the voltage between any live wire and the neutral conductor. The relationship between line voltage and phase voltage depends on the type of three-phase connection, such as Y or delta. In a single-phase system, there is only one phase and the line voltage is equal to the phase voltage. When working with electrical systems, it is essential to follow all applicable electrical codes and standards and to take necessary precautions to ensure safety. To further expand on the concept of grounding in electrical systems, it is important to understand the difference between system grounding and equipment grounding. System grounding refers to the connection of the neutral conductor of a power system to ground, while equipment grounding refers to the connection of the metal enclosures of electrical equipment to ground. The purpose of system grounding is to provide a low impedance path for fault current to flow back to the source in the event of a ground fault. This helps to quickly trip the circuit breaker or fuse, preventing electrical shock or fire hazards. The purpose of equipment grounding is to provide a low impedance path for fault current to flow back to the source in the event that the metal enclosure of an electrical device becomes energized due to a fault. This also helps to quickly trip the circuit breaker or fuse, preventing electrical shock hazards. The NEC provides detailed requirements for both system grounding and equipment grounding, including the types of grounding conductors that are required, the methods for connecting grounding conductors to ground, and the minimum size of grounding conductors. It is essential to follow these requirements carefully to ensure that electrical systems are properly grounded and that electrical hazards are minimized. In addition to grounding, overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current flow. Circuit breakers are reusable devices that trip when the current exceeds a certain level, while fuses are one-time use devices that melt and break the circuit when the current exceeds a certain level. The NEC provides detailed requirements for overcurrent protection, including the types of overcurrent protection devices that are required for different types of circuits, the minimum ampacity of overcurrent protection devices, and the methods for installing overcurrent protection devices. It is essential to follow these requirements carefully to ensure that electrical circuits are properly protected from overcurrent conditions. Furthermore, it is crucial to understand the different types of wiring methods used in electrical installations. Wiring methods refer to the ways in which electrical conductors are installed and protected. Common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheath cable. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the specific application and environmental conditions. The NEC provides detailed requirements for each wiring method, including the types of conductors that are permitted, the methods for supporting and securing the wiring, and the minimum bending radius for conductors. It is essential to follow these requirements carefully to ensure that electrical wiring is installed safely and correctly. In addition to the topics discussed above, there are many other important aspects of electrical systems that are essential to understand. These include voltage drop calculations, load calculations, power factor correction, and harmonics mitigation. Voltage drop calculations are used to determine the voltage drop in an electrical circuit, which is the reduction in voltage that occurs as current flows through the circuit conductors. Load calculations are used to determine the total amount of electrical power that will be required by a building or facility. Power factor correction is used to improve the efficiency of electrical systems by reducing the amount of reactive power that is consumed. Harmonics mitigation is used to reduce the distortion of the voltage and current waveforms caused by nonlinear loads. Each of these topics is complex and requires a thorough understanding of electrical theory and practice. It is essential to consult with qualified professionals and refer to relevant electrical codes and standards when designing and installing electrical systems. As a final point, it is important to emphasize the importance of ongoing education and training in the field of electrical work. Electrical technology is constantly evolving, and it is essential to stay up to date on the latest codes, standards, and best practices. There are many resources available for electrical professionals to continue their education, including online courses, seminars, and workshops. By investing in ongoing education and training, electrical professionals can ensure that they are providing safe, reliable, and efficient electrical services to their clients. Understanding line voltage, phase voltage, and the nuances of single-phase and three-phase systems is fundamental to electrical work. Correct terminology, safe practices, and adherence to electrical codes are all critical components of a successful and safe electrical installation. The differences between line and phase voltage can sometimes cause confusion, especially when dealing with different system configurations. For example, let's delve deeper into the scenario of a delta-connected three-phase system. In a delta configuration, the three phases are connected in a closed loop, forming a triangle. There is no neutral point in a pure delta system. Therefore, the voltage between any two phases, the line voltage, is the same as the voltage across each phase winding, the phase voltage. However, in some delta systems, a corner of the delta might be grounded, or a center tap on one of the windings might be grounded to create a neutral point for single-phase loads. These are variations on the basic delta configuration. Contrast this with a Y-connected system. In a Y configuration, one end of each of the three-phase windings is connected to a common point, the neutral point. The other end of each winding is connected to a line conductor. In a Y system, the line voltage, that is the voltage between any two line conductors, is equal to the phase voltage, that is the voltage between a line conductor and the neutral point multiplied by the square root of 3. Understanding this difference is crucial for selecting the correct equipment and ensuring proper system operation. Let's consider an example. Suppose a facility has a three-phase motor rated for 480 volts. If the facility has a delta-connected 480-volt system, the motor can be directly connected to the line conductors. However, if the facility has a Y-connected 480-volt system, the phase voltage would be 277 volts. Connecting a 480-volt motor to a 277-volt supply would likely damage the motor. In this case, a transformer will be needed to step up the voltage to 480 volts. Another important consideration is the type of loads connected to the electrical system. Single-phase loads, such as lighting and small appliances, are typically connected between one line conductor and the neutral conductor. Three-phase loads, such as motors and 8-track equipment, are typically connected to all three line conductors. In a Y-connected system, single-phase loads can be evenly distributed among the three phases to balance the load in the system. This helps to prevent voltage imbalances and improve system efficiency. In a delta-connected system, single-phase loads are typically connected to a single phase, which can lead to voltage imbalances if the loads are not carefully managed. Furthermore, it is essential to understand the implications of grounding in different system configurations. In a Y-connected system, the neutral point is typically grounded, providing a reference point for voltage measurements and ensuring safety. In a delta-connected system, grounding can be achieved by grounding a corner of the delta or by using a grounding transformer. The type of grounding used depends on the specific application and the requirements of the local electrical code. Grounding is critical for preventing electrical shock hazards and ensuring the proper operation of protective devices, such as circuit breakers and fuses. It provides a low impedance path for fault current to flow back to the source, allowing the protective devices to quickly trip and energize the circuit. In addition to understanding the technical aspects of line voltage, phase voltage, and grounding, it is also important to be aware of the relevant safety regulations and industry standards. The NEC is the primary standard for electrical installations in the United States. It provides detailed requirements for all aspects of electrical wiring, including conductor sizing, overcurrent protection, grounding, and wiring methods. It is essential for all electrical professionals to be familiar with the NEC and to follow its requirements carefully. Other relevant standards include those published by the Institute of Electrical and Electronics Engineers IEE and the National Fire Protection Association NFPA. These organizations develop standards for a wide range of electrical equipment and systems. Staying up to date on the latest standards and regulations is crucial for ensuring the safety and reliability of electrical installations. Furthermore, it is important to emphasize the importance of proper training and certification for electrical professionals. Electrical work can be dangerous, and it is essential to have the knowledge and skills necessary to perform the work safely and correctly. Many states and local jurisdictions require electrical professionals to be licensed or certified. Licensing and certification typically require completion of an apprenticeship program, passing an examination, and continuing education. Proper training and certification demonstrate a commitment to safety and professionalism. In conclusion, understanding line voltage, phase voltage, and grounding is fundamental to electrical work. The relationships between these parameters depend on the system configuration, whether it is Y-connected, delta-connected, single-phase, or three-phase. Electrical professionals must have a thorough understanding of these concepts, as well as the relevant safety regulations and industry standards to ensure the safe and reliable operation of electrical systems. Continuous learning and adherence to safety protocols are key to success in this field. It's also important to address some common misconceptions about line and phase voltage. One common misconception is that phase voltage is always lower than line voltage. While this is true in a Y-connected system, it is not true in a delta-connected system, where the phase voltage and line voltage are equal. Another common misconception is that the neutral conductor is always grounded. While this is generally the case, there are some exceptions, such as ungrounded delta systems. It is important to understand the specific grounding requirements for each type of electrical system. Additionally, it is important to remember that the term phase in a single-phase system refers to the entire system, not just one of the wires. In a 240/120 volt single-phase system, there is still only one phase, even though there are two hot wires. The two hot wires are simply derived from different points on the transformer winding. Furthermore, it is crucial to use the correct terminology when discussing electrical systems. Using the wrong terminology can lead to confusion and misunderstandings. For example, it is incorrect to refer to the two hot wires in a 240/120 volt single-phase system as phases. The correct term is legs or lines. Another important consideration is the impact of harmonics on electrical systems. Harmonics are distortions of the voltage and current waveforms that can be caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can cause a variety of problems, including overheating of equipment, increased energy consumption, and interference with communication systems. It is important to identify and mitigate harmonics in electrical systems to ensure their reliable operation. Harmonics can be mitigated by using harmonic filters, line reactors, and other specialized equipment. Finally, it is essential to understand the importance of proper maintenance for electrical systems. Regular maintenance can help to prevent problems and extend the life of electrical equipment. Maintenance tasks include inspecting and testing circuit breakers, fuses, and other protective devices, tightening connections, and cleaning equipment. Proper maintenance is critical for ensuring the safety and reliability of electrical systems. To summarize, a clear understanding of line voltage, phase voltage, grounding, and related concepts is essential for anyone working with electrical systems. This knowledge, coupled with adherence to safety regulations, proper training, and ongoing education, ensures safe and reliable electrical installations.